you. Assalamu alaikum warahmatullah. A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Well, I guess they are trying to find my slides. In the meantime, I can say a few words because I was going to digress from the topic. And since it's Salam and Quran is highlighted in this seminar, I want to say something about that first. So what was Professor Salam's advice to me? I grew up in Rabwa. I did my FSC and I topped the list of the board, all the board candidates. So my father wrote to Salam that what is your advice for my son, what he should do, in what area of research he should go into? And Salam responded. My father showed me the letter. In the letter, he written that he should become a CSP officer. You know, CSP was a government ladder that you can reach the upper echelon of power. And the same advice was given to Salam by his elders, which he did not take. And so, of course, I was not going to take advice. But I wondered about it, why he gave me that advice. And even though I met Professor Salam in Imperial College, I dared not ask him this question. But later on, I reflected upon that, and I will tell you in the end, if they can find my slides, how I rationalize that. Other thing is about Quran. Can you not? Okay.
You can look down there.
Right. Okay. So let me first go back to the next slide. Knowing the unknown or scientific research is a Quranic challenge. In the Surah Baqarah, the first few verses of that, it described the 4 pillars of success. Ulaika humul muflihun, right? The first one is yu'minuna bil ghaib, that to believe in the unknown or the unseen. In my view, that's a challenge for scientific research. Of course, there are 2 lanes you can say. One is the spiritual world, one is the material world, and it applies to both worlds. And these 2 words are intermingled, but let's keep them separate first. So spiritual world, you try to reach the God, right? You believe in that. Just believe is meaningless, okay, in my view, unless you try to attain that, what's beyond what you know. So let me come to the material world. If whatever we see or we know, God tells us there is much more beyond that, okay? So believe means that you're trying to find out what's beyond that, what you know. So the example here is the electromagnetic spectrum. So what we know is at some point, 200 years ago or more, all we could see was the visible light. In the middle of that figure there, the light, that's 400 to 700 nanometer wavelength wave, right? That's the visible light we would see. But 200 years ago, some scientists, mathematicians worked on it, in this case, Maxwell. He put forward a theory that no, there is much beyond that. So this figure shows you all the waves of the electromagnetic spectrum, from radio wave to gamma waves, large wavelength. That's what we all use now for communicating in the space and everywhere, and your cell phone, everything. Some of these waves, different wavelengths of frequency are being used. So there is all this benefit that you're achieving just because people worked on it to understand what's beyond. And Quran says also that no matter how much you find out about these secrets of your Lord, there is much more. So this is a never-ending search, and that is a scientific research. Let me come back to my original topic here, sorry. So my area of expertise is computational fluid dynamics, and in there, we use computational simulations to do all these designs of various aircraft. I have a subsonic aircraft that will be built soon, a supersonic aircraft that's being flying testing this year. this moon rocket or landing on the Mars, all these. So there was a phenomena earlier when we did not have computers that you have, and this is also a scientific process, learning process, that you have some empirical knowledge. You try to understand that, so make some theories, and then do experiments to prove those theories or negate those theories. But now with the advent of tremendous power of computers, we use simulation instead of experiments, or just to supplant experiments. So role of experiments is decreasing, role of simulations is increasing. And so this is a much deeper subject, so I don't want to go into CFD part of it, but supercomputing, because now computational science is becoming a field which is impacting all fields of science, physics or chemistry or biology or economics, where you can try to simulate whatever you're trying to learn. So let me take you back 20 years ago. This is a front page of New York Times. That's the news, if you probably can't read it. It was a Japanese Earth simulator computer that they developed in that year. And the story says that this computer is 20 times, is much faster than whatever exists in US right now, at that point. And you can see that room full of computer. This was 36 teraflops. That means 36 trillion mathematical operations per second. When I did my PhD, this was 36 megaflops. That means 1 million times slower. And come to this year now. Now, this is the era of exascale computing. That room full of computers that you saw, I can carry in my hand now. So this frontier computer at Department of Energy lab, now they have set up 100,000 of these in one room. And that gives us 10 to the 18 mathematical operation per second. Okay, that is, again, million times faster than what we had in 2002. And this is impacting all the fields of physics, chemistry, biology, anything you want. Now, so Professor Hamid Nassim talked about he developed the hardware, right? So he talked about 0 and 1. So the classical computing is 0 and 1, classical bit. The new paradigm in computing is quantum computing. It uses quantum physics, which is a completely new way to store and process information. And the difference between quantum bit and classical bit is, in classical bit, you can only have 0 and 1. In qubit, you can assume values 0 and 1 at the same time. Okay, my time is up, so I'll go fast. So this is an area that is now currently, a lot of companies are investing because this impacts encryption and everything. Other areas of research of human brain projects, because I thought there's doctors here and some probably are neuroscientists and so forth. This is an area which is now developing based on how our brain works, try to understand that and use that in this neuromorphic computing. The beauty about that is it can create both processors and memory together. Because the bottleneck in the classical computing is the information exchange between processor and memory. This computing can be done simultaneously. Right now, Intel and Sandia Lab has assembled a neuromorphic computer with 1 billion neurons. A human brain has 80 to 100 billion neurons. I will skip this. So scientific research is hard, but it is a Quranic directive that believe in the unknown. You have to believe. That means you try to find out what you don't know. And so in NASA, when Kennedy put together this challenge, he said, we do things not because they are easy, but because they are hard. And I think my Professor Salam's advice to me, he obviously didn't know me. not everyone can do research. It's hard. So a CSP officer, if someone is asking for advice, if he works hard, he can get there. But scientific research, you have to have a fire burning inside you. Only then, because you try things, you will fail. Probably you will fail 20 times. Maybe one of these times you will succeed. And that kind of fire has to be burning in one inside to reach that goal. And I think this is an area FOMC Commerce has been stressing also the young people need to go into research, but they need to realize that they really get into it. And one thing I want to say about Salam also is he walked both lanes, the material research and trying to find the unknown, and also the lane of the really spiritual lane. And that is how he is unique among scientists. And that also made him a humanitarian. So for example, Steven Weinberg, who shared the Nobel Prize with Salam, said that when we got the prize, I put the prize money in my bank account and Salam started a scholarship. So that shows the humanitarian aspect of Salam. And that is why he's great among the Nobel laureates himself.
Jazakallah.